Alright guys, so I have given you a little overview video before this one about what makes two events independent versus dependent. So I'm going to assume you've seen that idea. And that all I need to tell you here to start is that for two events, for event A and event B to be independent, then the probability of A and B occurring needs to be equal to multiplying the probability of A times the probability of B. That's what this little statement means. Because these two things just sitting next to each other represents multiplication. So again, if I can take the probability of those two separate events and multiply them together, and it equals the probability of both of those things happening, then I know that they were independent. There isn't something special about the relationship that makes them dependent on each other. So we're going to do a little test with a couple practice problems to see why they are independent or dependent. So the first example I have here is two events, the probability of J and the probability of K. So if they are truly independent, I should be able to take their two individual probabilities together. So 0.50 times 0.40, which gives me 0.20. So if they were truly independent, I should have been able just to straight up multiply those two probabilities together, and it should have been equal to the probability of them both happening. Because remember, that's what this little symbol here means. That little symbol means and. Well, apparently it's not the same, because the problem told us that the probability of both of them happening is 0.3. So that means there's something about that relationship that when the two of them happen together, it makes it more likely to happen because it's 0.3 than if they just happened independently. So because I multiplied their two probabilities together and I got a different number from the probability of them both occurring, these are not independent. In other words, these are dependent of each other. Okay, for this next one, you take a stab at it. Okay, multiply the two. You pause the video, try it out for a second. I'm going to assume you've done that step, that you paused the video, you tried to see on your own whether they were independent or not independent. I'm going to go ahead and work it. So I take the probability of each event happening separately, and I'm going to multiply it, and that gives me 0.12. And that does, in fact, happen to be the given probability of J and K occurring. So because those two probabilities are the same, that means that there's no special relationship that makes their probability dependent on each other, doesn't make it change. So therefore, these are independent. One more, last but not least, you try it out. Okay, I'm going to assume you've done that. So I'm going to take the individual probabilities of J and K happening, and then I'm going to multiply them together. And if I get 0.15 times 0.5, which gives me 0.075. That is not the same probability that is given to me that if both of them occur together. So therefore, these are not independent events.